In this video, we'll see the second and third practices that make up the larger instructional activity we refer to as eliciting students' ideas. The second practice is selecting which of the students' ideas, past experiences, or puzzlements to make part of a public record. After the lesson is over, the teacher does a quick assessment of how the students talked about the anchoring event and uses that information to adapt further instruction. In a previous lesson, we've introduced the idea that the Antarctic is home to a very important ecosystem. We've also introduced the puzzling question: why would one species in this ecosystem have their population drop so precipitously over the last 30 years? I want my students to start reasoning out loud, not just with me, but with each other. They can't do this, however, without at least some cursory understanding of the organisms in this environment. We have some of these animals that affect the lives of penguins are below the surface most of the time, leopard seals, for example. And we're going to introduce this idea of krill, who forage underneath the sea ice, so they need sea ice. And then there's also this microscopic form of life called phytoplankton. These are players in this ecosystem that are really important, but in different ways. And we're going to study this, but I want to give you more information right now in the form of some written text, so you can create what you think is a set of links between these organisms. And we'll, as we learn more in this unit, we'll shift these links and add more detail to what it is we think we know. So I've got 5 groups, I've got 5 sets of materials. You guys should work together, you guys can work. In this activity, I try to make the instructions as clear as possible, so I can spend my time circulating around the room and talking with the students about science ideas rather than about procedures. This one-pager on building an initial model helps students understand why it's so important to do this work, how we're going to go about doing the work, and even a representation of a final product.
All animals in the Arctic eat krill.
Your initial model is going to be some way in which these organisms are connected, and then you're going to write on the line how they are connected. And yours is very likely to be different from your life. It may appear that I am now providing information rather than eliciting ideas. However, I cannot see students' reasoning if they have no content knowledge to reason with. So I provide them with some very basic information about different organisms in the Antarctic in order to hear how they talk about ecosystems. What am I listening for? I would want to know if they talk about any of these species as being adapted to the environment. I'd like to listen for talk about organisms being part of populations whose individual members show variation in their traits. Some students may talk about organisms that compete for valued resources. I'd like to hear if and how they think about climate change and how this may affect all the relationships they are currently mapping out. Some of them have already mentioned climate change, and I plan to use what they know in upcoming lessons. Finally, I'm listening for any suggestion that they are using the idea of energy as a way to make sense of the ecosystem and how it might change over time.
Oh, smaller seals eat mostly krill. Larger seals. If we're saying like this is where energy is going, this is where food is going, like, and this should be somewhat above. The seal should be somewhat above the penguins, right?
Do we have the ability to make our? I wish we had cards that we could like write on and like.
We can just like draw our own card.
Larger leopards.
So this is on top of both, so they maybe eat both, or did you want it?
There is something that you think is missing from this the ecosystem that you know about that I didn't include. You can write them on here. As I move from table to table, I model how to interact with students in small groups. I use discourse moves that get them to say more about their current thinking. Tell me what you've been talking about.
We were talking about maybe adding a whale into our system.
Do you want to add a whale because you think it completes some part of this story? A story that you've got going on? Or have you not yet started to connect the ones you had.
Connected the ones that we had, and then Paige asked if anything needs a leopard seal, and I said,
Tell me about the, you've got like a stair-step pattern. Tell me about why it's a stair-step pattern.
Well, because we think there's only really one. Like, we think the seal probably really only eats penguins. The penguins really only eat krill, and krill really only eat five.
I don't know what it gets so low.
I mean, like, I think we could move it around and have it be the same.
Something that's just kind of like
I think.
we can maybe add another food source to this. Maybe here.
What if I took out half the penguins? Half this population, we would say, for some reason, got removed.
Then you have to add that half onto the krill and then take that half away.
It would probably, like, after enough years, though, balance back out again to, like, carrying.
Yeah.
Let me ask that question. Let me ask a simpler question. You take half the penguins away. Just tell me the story about the krill for the next couple of years. So taking half the penguins away, what's the story of the krill for the next 2 years?
But then what happens when they eat all the phytoplankton?
So we're going to fast forward. We're going to say you've had 10 minutes to talk about this, and I have gone around, and if people have, like this group and this group already, they had their links made pretty early, so what I started to ask them was, what if one of these populations went up for some reason, or one of these populations went down, or you introduced a new predator, like these folks have orcas, they have killer whales. What if you introduced them or you took them out? So for some of the kids who got done early, I started talking about disturbances in this ecosystem, in their ecosystem. So now at the end of class, we need to create a list of hypotheses, a record of kids thinking. After doing all this, what are kids thinking now? And then we'll work with what they're thinking now for the rest of this unit. We'll work on this list of hypotheses. So Dennis is going to do this.
We've been working on our initial models with our 4 different organisms. Perhaps we've included some organisms, or perhaps included something else into your model of the ecosystem. And now what I want us to do is to create a hypothesis about why the interactions are going on in this ecosystem the way that you saw them. So in previous units, we've created hypotheses initially about certain ways that we represent our unit. So I want to remind you that your hypothesis does not have to be correct, that we are open to any kind of hypothesis, and I'm not asking for the right answer, I'm asking for what you think is going on.
At this point, I press the pause button and ask my novice teacher to be more specific in what he's asking of his students. We want to be specific about his hypothesis about what? The hypothesis is about why the Adelie penguins' breeding pairs are going down. That is what we want to be specific. Okay. That helps them.
So I created a couple of sentence starters, maybe to get us going. We think the Adelies are declining because, and then whatever the hypothesis that you initially came up with, or we think that the explanation has something to do with blank. So,
You better do a turn and talk to your neighbor here, I think. Okay.
So, for about 30 seconds, turn to your neighbor and talk about what your hypothesis was.
I think the populations are declining because there is less sea ice, which means there's less.
We think the delis are declining because.
I agree. I want to flip it though. So I think there's less Adelie because there's less krill, and I know this because there's less sea ice.
All right, everyone, please wrap up your conversations in the next 5 seconds.
Right, because there's less.
So ice is decreasing.
I need everyone's attention up here in 3. Stop the conversation. 2. Last word. 1. Thank you. Did you have something to start with, Esther?
Oh, no, I can start, I guess. We think that the adelies are declining because the krills were dying, and they seem to be important because they're called something called the keystone species.
Okay, can you tell me why you think the krill were dying?
Maybe the phytoplanktons were dying.
Okay, so the krill are dying because of something that has to do with the phytoplankton dying, and the krill are dying, so there's less Adelie penguins. So why the krill dying affects the Adelie penguins?
Because the Adelie penguins feed on the krills. So if they die, then the penguins have less food.
Okay, so did anyone?
Dennis, let me interject here. So in this, when you have these hypotheses coming out, this is a time when you can actually take what Esther is saying more at face value without probing, because what you want to do is see if what other hypotheses come up actually interact with hers.
Okay. Yes.
Our group added sea ice on a card because it was mentioned in every single animal card except for the seal card, I think. But then we realized that the phytoplankton have to have sea ice to live. And if the sea ice isn't there, they won't live, and then the krill won't live, and then the penguins don't have anything to eat. And then I was wondering, like, what happens to the seals? I mean, I wish we had data about the seals.
Scott, did you want to?
Yeah.
Well, wait a minute, you better revoice that, because that was an extended statement with a lot of stuff in it that other kids might not have heard, so I had to revoice it to try to simplify and streamline what Molly said.
So Molly, what I'm hearing you say is that you've added sea ice into your model because it interacts with all the other organisms. Is that what you were trying to say?
Yeah, and also add to Esther's point, because even before the phytoplankton die, the ice goes away.
Okay, so what I'm hearing is that one of the possible reasons that the krill are dying is a decrease in sea ice.
Okay, go ahead and write that. That's what we're putting up there.
We were thinking that if the krill goes down and then the penguin population goes down, then what we notice is that the leopard seal eats both krill and penguins, and so we were thinking that if the penguins population goes down, then the leopard seal might start increasing the amount of krill that it eats, and so the krill population gets even smaller.
So what I'm hearing is you say is that the Adelie penguin population is decreasing because it's decreasing?
Or no, but if it does decrease, then the leopard seals start eating krill.
Okay.
I think it sounds like why they're declining. Maybe not initially, but they maybe further decline, like later in the graph, because there's a feedback loop.
Are you saying that would make
Oh,
it even worse for the Adelie
Yeah,
penguins
yeah,
because
yeah.
more of the krill are getting eaten?
Yeah, that makes sense.
We'll debrief this next Tuesday. But I just want to show you how difficult it is to do this, how much you have to be thinking as you get an initial list of hypotheses. Right now, we've got 3. You probably want to get 1 or 2 more up here, like 5. And Dennis didn't have time yet to ask about how these might interact with each other, although I guess you did start asking people how hypothesis A impacted hypothesis B, so.
Right, I guess I forgot that the second part, we think something of the explanation has to do with, they're not actually coming up with a full hypothesis when Scott had this idea of 2 things impacting the Adelie penguins. I was kind of like, well, that wasn't really a hypothesis, it was just, that's kind of what happens afterwards.
Yeah, usually I would start asking kids about this, just fill in the blank. I think it's got something to do with X.
Right, okay.
And then if they get braver as you continue to do this, activity, then they can start themselves saying, I think it's got something to do. Here's an explanatory statement I've got.
Right.
The final practice of eliciting students' ideas is to review what students have said and drawn that gives me insights into their current thinking. When I look at the models they've created, I see that, understandably, they've focused on what feeds on what. Some groups have added other organisms and the sun as an energy source. Others have recognized the importance of sea ice in this ecosystem. Most have drawn their models as stable ecosystems. But only part of what I've learned from them is embedded in these models. I have to recall their talk as well. From their small group and whole group conversations, I know that they are hypothesizing about changing conditions for these organisms, but they don't yet understand the cascade of effects that originate from climate change or from shifting competition for resources. And energy is not yet part of their explanatory language about how this ecosystem operates. Building on what they now know, we move on to the next set of practices, that of supporting ongoing changes in their thinking.